darker in here for some reason. All right, you're pretty good. Oh, there you go. That's why. Get over here. I'll come over here and you can come over here. So I wanted to give you number 3 because a lot of the telescoping problems you see all look the same. Some of them you use partial fractions to kind of break it up. Some of them are already 2 fractions. So I want to give you a telescoping series that was built differently. And I also want to give you one that actually diverges, because normally 2 things happen in telescoping. They look the same, and they converge. And you're like, okay, so then it's unfortunate students go, okay, I know exactly what a telescoping series always looks like, and I know it always converges. Those are 2 wrong things, yes? So this is a desperately needed counterexample to all that. How the shit do I write that as a, what is telescoping? What does that mean? Yeah, there should be internal terms kind of canceling, yes? So that you end up with just the 2 extremes. So that's kind of like, telescoping is literally, you have a telescope and you push it down so you end up with the end and the beginning. And that's all you have left. Okay. The alpha and the omega. Shut up. You're no good. Get over here. You're no good. You're no good. Okay. So how do I do that?
Rewrite the natural log.
Yeah. What property in natural logs do we have that's going to help us out here? Real quick, what are logs? Don't tell me they're trees you cut down. What are logs? Anybody? What's log base 3 of 9?
2.
Why?
Because it's 3 raised to the second.
So logs are powers. Yes? Logs are powers. So every property of logs is a property of powers. Why? Logs are stupid powers. So do you all agree, what's the base of this log?
E.
So these have the same base. They both have a base of e. What do I do when I divide things with the same base? Subtract powers. I subtract the power on this guy. Holy shit, Jeff. Give me a break. It's been a week since I really had to write for anybody else. Minus, so I subtract these 2 powers. And I put extra parentheses I don't really need, but it's okay. Do you guys see that? Logs are powers. When I divide like bases, I subtract the powers. That's why the property of logs is that. Nothing new to memorize. You already have powers memorized. Why is that telescoping? Well, if you write a few terms out to the nth term, yes? So the idea is you investigate Sn. So can somebody help me start writing this? No? Yes? Sorry? You need one? Okay. Anybody else need a practice test? Okay. What's the first, what's A1? What's A1? No. I mean, from the way we've rewritten it, sorry. Here, what's A1? You can do it. What's A1? Natural log of?
2.
2 minus? Natural log of? 1. Okay, and we know that's 0, but it's okay. Plus, so this is A1, what's A2? And you can see these cancel, yes?
Mm-hmm.
Yeah.
You with me? And so all we have at the beginning is this, which is 0, yeah. And then it's got plus, what's A3? These cancel.
Mm-hmm.
So what's if I keep going, I'll get natural log, if I go to the n minus 1th term, I'll get this minus this, plus, and then the nth term will be this minus this. And then this would cancel with the one before, so what's at the end? I get 0 plus this. All right, let me stop for a minute. I need you guys to focus. Let me zoom out. Okay, I've done exactly the same thing you do with telescoping. Why am I looking at Sn? How do I find the sum of a series? What's the most direct way to find the sum of a series? This is really important because I think for some of you guys this got lost, and it might be partially my fault, but I really want to make this hit home. There are certain series that we have proven the sum of them, but if you go back to what we did the same thing. How do I find the sum of a series? What does Sn mean? Partial sum up to the nth term, yes? And what is the entire sum? How far does that go? What value of n? It's the limit as n goes to infinity. So what do I do? If I can write what Sn is, how do I get the actual sum? I let n go to infinity. So what's the limit as n goes to infinity of this? Because that's what Sn is, yes? Did we just prove that's what Sn is? So what's the limit as n goes to infinity of this? And therefore, we just shown that the series diverges. Good. So it kind of gave that away to make sure you were on the right track. You guys all with me? That should feel very similar to what we did with telescoping. It is different for sure, because it's natural log and stuff canceled that didn't, the first thing canceled, but I just wanted to show you a series that is telescoping, that is not just the difference of two fractions, and that diverges. Because I think most telescoping series you saw were fractions and they converged. You're like, oh, it's always, no. Maybe, are you guys, is that okay? Who asked the question, is that all right? It almost has to be all right, because they basically did the whole thing. Okay. Yes?
So I tried using the Nibble test on it, and I still got that it was divergent. So would you accept that, or is that not?
You tried using the what now?
Nibble test?
I would not accept it. Why? Why would I not accept it? And you're like, I don't know, man, I'm asking you. Anybody know why I wouldn't accept that? Because you're an asshole, Jeff. No, come on. That's what I think you sound like, by the way.
It says use telescope.
Yes, it says use telescope. I'm sorry. So, I mean, now listen, real quick, Christian. If you did the interval test and you applied it correctly, and you got the right conclusion and everything, I might not take off all of this. I'll take off most of this. Are you with me? So, like, I still, at the end of the day, if I give you a problem, I'd say do it this way, and you're like, I really don't see how that works, but I know I can do it, I'm going to do it this other way. I will give you something. Because you've shown me, but the point of this problem is, I need you to know what telescoping means, I need you to know how to try to rewrite it, I need you to know how to apply that idea. That's what I'm testing with this problem. I will give you some points, because you've shown me you kind of know how to do it in general, but I'm going to take up most points because you're not doing what I'm trying to test. Yeah. What's next? Anything next? Or are we done? What's happening? Does anyone? Okay, I'm just going to. Yes. Oh yeah, look at this guy.
If it's conditional, that means it's still divergent, but it still applies.
So conditional is convergent. It's just not absolutely convergent. And I want you to understand.
Like through and through?
Huh?
Like through and through?
No. Absolute convergence is kind of, I need you to really understand what I'm about to say. Absolute convergence is kind of silly. It's extra. We're like, okay, you passed, but what if I add weights to your angles? Can you jump then? So it's like, this series converges. Yes, you have to show that it meets the requirements for the AST, but once you do, is the limit of the 0? Obviously, yes, you can show me. And is it decreasing? You can show me that. If those two things are true, this converges. We say it converges, and I told you guys, do you guys remember what I said about the word conditional? It was kind of stupid. We're like, based on the condition. that you leave it the way it is. And we're like, that's not a condition, what are you talking about? Okay, so it's kind of like if you run a race and you do it in so much time, they say, well, that was conditional. Nobody put a big backpack with 40 pounds in your back. And you're like, what are you talking about? I did it. So absolute convergence is like putting a backpack on you with 40 pounds in it and saying, now do it. If I take the absolute value of that, should it be harder now for it to converge? Hell yeah, because now some of its terms aren't taking away from it. They're all added. So it's absolute convergence is sort of like, okay, you converged. What if we take away all the negatives? Do you still converge? It's an extra thing. So I would say this series converges. Does it converge absolutely? Can you guys see why not? I mean, you have to show me, if you write it out, you have to show me, but basically what is this trying to be? What is that series trying to be?
Harmonic.
Harmonic. So if I take the absolute value, it's basically 1 over n that's going to diverge. But I would say that series converges, and if I want to be a little more specific, I would say it converges conditionally. The condition is we leave it alone. I want you to be able to understand that I find that silly and to still be cool with it. It's just the convention we came up with. That's a way to distinguish what kind of convergence it has. It's going to become a little more obvious later when we do some more tests that have absolute values built into them, while we even have this idea of absolute versus conditional convergence. But for right now, it's not, it's kind of like just an extra silly, oh, can you pass this? Ooh, right? Maybe. Okay. That was a really good question. I love it. So if I said, does that series converge? You should say yes. If I said, does it converge absolutely? You would go, no, it converges conditionally. So in a test, I do want you to be more specific inherently. If it converges, what kind of convergence? Part B, real quick. Part B, what would you test first? Absolute or conditional?
Absolute.
Because you can tell what's it trying to be. What's part B trying to be?
1 over n squared.
If it converges absolutely, does it converge conditionally?
Yes.
Hell yeah, I want this to make nothing but sense. If all the terms are positive and it converges, if you make every other term negative, it's like, yeah, that's going to converge like even more, right? Even though that's a silly thing to say, but you see what I'm saying. Okay. Yes, I'm sorry. Does somebody have a question more about? I passed somebody by. Was it you I passed by? You. Did you have another question about part A or? I'm sorry.
It's okay.
It'll come back. What's that?
Just about this, so like, for deciding whether to test for absolute or conditional divergence, if we can see that it would like, if it's kind of like seeing what it's trying to be, right? And then if we know
That's-
that it would converge, then we test for absolute divergence.
This one. You see, it wants to be 1 over n squared.
Yeah.
I don't do I don't do AST. I don't do alternating series tests. I don't. I just take the absolute value and show. Because if it converges absolutely, it converges conditionally. Yes? It just simply converges. Are you guys at all with me? So on 8B, if you did not apply alternating series test, that's fine. I wouldn't. Because if I just take the absolute value and it converges, it's obviously going to converge if you left the negatives in. So don't even do alternating series test on a problem like this. Now, if you can't tell, go ahead and do it. Why not? All right. But to be honest, if you can't tell, I'm going to still do absolute first. Because if it does turn out to be convergent, I'm done. If it's divergent, absolutely, I'm like, oh shit, now I got to go back and do alternating series. I guess. You guys at all with me? So in that case, I would just rule out absolute convergence. This one you can rule it out before doing any work, yes? Because this one's trying to be 1 over n. I'm going to just check conditional because I already know it's not going to converge absolutely. Are you guys with me? It's only if you can't tell on sight, then you would try both, right? Okay. Yes.
For 6B, I had a quick question for it. I know it says, try the comparison on the following.
Oh, yeah.
Now, I understand, obviously, I'm going to compare it to 1 over n to the 11th.
Yes.
But what if I left the cosine to 1 squared plus 1? Because when I do the limit comparison, it'll be easier because I'll cancel out cosine 2 squared plus 1.
How would that cancel that out?
Because when I do the reciprocal, it's
No, you don't do the reciprocal. If you're doing limit comparison, what is your Bn? You just told me your Bn is 1 over n to the 12/11.
No, I understand that. I said if I did leave that and I did do
Then you wouldn't know what Bn does.
Okay.
Does that make sense?
But
Now, you could, now, all right, I really want everybody to understand this question because it's a really good question. It's a trippy question. And another trippy question is, where's my good pen? Are you my good pen? All right, we'll find out. Let me see, I gotta find some blank paper somewhere. Oh, maybe this one, this will work. All right, so your question, this one, okay. So, if you say Bn, it wants to be this, sort of, yeah? Not really, but sort of. That's the closest thing I can see. But you're saying, what if I left this like this? Yes? Then you have to show what this does. Right? Then you kind of added a layer. That is not automatically obvious what it does because it isn't a p-series. It's got extra stuff on top. So you'd have to do a whole test to this by itself. And then you could do limit comparison. Limit comparison requires you to know for certain what Bn does. If I get the limit as some finite number, I know they both do the same thing. But if I don't know what Bn does, I don't have an answer. Then your answer would be, it does whatever this one does. You figure that out, Jeff. I'm like, minus everything. Right? Does that make sense?
Yeah.
It feels frustrating because you know cosine is bounded, squared is between 0 and 1. The top is basically finite, but too bad. These tests, if I want to apply them directly, have requirements. Yes. And the whole purpose of this, I designed this so that limit comparison worked on A. It did not work on B, but direct comparison works on B. And of course, anytime I see like a cosine or something, I think direct comparison because it has inequalities built in. Sort of like the squeeze theorem kind of thing too. And then both direct and limit should fail in part C, and then I have to use interval testing. So I kind of wanted you to see, most of you guys love limit, it doesn't always work. And then sometimes direct doesn't even work. And you're like, oh shit, I gotta fall back to something else. You guys fall? Okay. Yes?
So if you try LCT, you should see that it's oscillatory divergence. And then if you try the DCT, you'll actually see it.
Yeah, LCT won't work unless you do what I said. You actually have to test Bn by itself. You have to show what it does. You can't just kind of assume what it does. And you could use direct comparison, well, and then you would just be using direct comparison, which is kind of silly. I could use direct comparison on this to show that this converges, and then I go back, and you're like, why didn't I just do direct comparison from the beginning? I still have to show what Bn does. You just kind of like shuffled it down a layer. You added another layer. Yes? So DCT should work beautifully, quickly for this one.
And to show that LCT doesn't work, you still want us to like take a limit and like at some point realize like okay, this doesn't actually happen?
Yes, totally. Yes. There's no finite limit for this, right? I mean, no finite limit. It's not infinite, but it's oscillatory. So the limit comparison officially fails because it doesn't have an L. You could argue, well, it's always between, but sometimes it's zero. In that weird way that this oscillatory thing works. Sometimes it's 0, and that would be inconclusive.
Oh, yes.
Okay. So this is a trippy series that you could potentially use limit comparison for, but it would be so much harder than just direct comparison. Yeah.
For the denominator, can you show me like how you
So basically, when you're trying to see what something's trying to be,
Oh,
I'm sorry.
I get that. It's just more of how did you change n plus 1 times the root of 11 and into n?
That's what I'm saying. When you're trying to see what something's trying to be, you normally take away the lower degree of terms. Because the highest degree is going to be what it's trying to be. So the first thing, and this step, determining Bn, I don't have to show inequalities, I don't have to show, I just have to kind of see, what is this trying to be? And that could be completely, you don't have to show me shit. Now, if you say this is trying to be 1 over n to the 7th, I'm going to be like, okay, that I need you to show me. But if I just take the plus 1 away, and I just make the top 1, do you agree with me that the top is finite? So it almost, in fact, it's at least 1, if not 2, yes? So it's basically a constant over n times n to the 1/11th. Is that cool? Because if I just take the plus 1 away, it's n times that. And of course, I add powers, and I get 12/11ths.
Okay, so that's not like actually multiplied out, you took away something.
Do it again.
You took away something in the denominator to get to that, so
Yeah, I just took the plus 1 away, and now I multiply.
that's what I was confused.
And I add my powers. Sorry?
No, you're good.
Good? Okay, good. Okay. Sorry, Macy. Sometimes we talk past each other, and that's always exciting. By the way, I'm recording the screen. One of my other students pointed out, I don't know if you guys have noticed in the videos, there's like a really bright, because this guy, he's like, can you turn the light off? If I turn the light off, then this is gone. So I'm going to try recording the monitor instead, in case you look at the videos. If you don't, I don't care, because they help me to remind me what I did. What did I talk about last time? Oh, yeah. Yeah.
For part C on that one,
Yeah.
is that just basically trying to behave like 1 over n?
That's the neat part. Did anyone do part C? Did anyone try part C? Yes? What happens when you try to do limit comparison? I mean, like Christian just said, the first step is a little wonky. It's like, what the shit is this trying to do? So one thing that shows you limit comparison will be difficult, if not work, is what is it even trying to be? So it feels like it should, the bottom, well, here. N natural log of n, how does that compare to n?
It's a little bit.
Yeah, after like e, this one will be bigger, yes? Which means 1 over n ln of n is going to be smaller than 1 over n, yes? What is 1 over n? So right here that tells you, this is kind of telling you why direct comparison is not going to work, because that is smaller than something that is divergent, right? And it's bigger than 1 over n to the any other power. You guys kind of with me? So it's no good. I don't know if you guys are with me. So direct comparison is not going to work. Why did I even write this down? Sort of like if I'm doing limit comparison, I have to figure out what it's trying to be. So this is a good place to start with what is it trying to be. And the closest thing I can see it's trying to be is 1 over n. Right? I desperately want you to understand. The only thing that Bn makes sense would be 1 over n. Is everybody kind of with me? But that's not right. Because ln of n does add something, yes? But it adds so little. This is why this problem is so cool. It adds so little that it effectively, in the limit, adds nothing. That is effectively the same as 1 over n, which is trippy as shit. ln of n grows so slowly that series is effectively the same as 1 over n, because they both diverge. And I need you to understand this. Is everybody with me when I say 1 over n is a knife edge? If p is 1, it diverges. If p is 1 plus 10 to the negative billion, trillion, zillion, quadrillion, it converges. That is knife edge. Do you understand what I'm saying? I need you to understand. This is so cool. So if I just multiply n by n to the point 0.0008 billion zeros 1, it converges. But if I multiply n by ln of n, it doesn't. That is trippy as shit. Sorry, I didn't want to go that deep into this problem. Once you integrate it, it's stupid easy. That's just a u sub what to do. And then you find out it diverges. You don't have to think further than that, but if you do, it'll freak you out. Maybe. And if it doesn't freak you out, okay. It should. Yes.
On the on natural log n for 7b, you're asking that which test we'll choose. Can we say direct comparison? Can you directly compare 1 over n or natural log n to 1 over n?
Oh, no.
No.
Mm-mm. Anyone see what 7B is all about? 7B is Crouching Tiger, Hidden Something. 7B is directly something. What will cosine of n pi always be? What's cosine of 2 pi? 1. What's cosine of 3 pi? What is it? Negative 1. What's cosine of 4 pi? What's cosine of 5 pi? What is it? What kind of series is it? Alternating, kick-ass. So, negative 1 to the, let me be very careful, n, can be written as this. They're the same thing. They're equivalent. If you get up high enough in mathematics, I had a sheet of expressions that were equivalent to 1. Because if I could just multiply by an expression that's equivalent to 1 wherever I needed to. And it's so cool to get high enough in mathematics, you're like, what's 1? It's this, it's all this shit. If I put that in there, it simplifies and it becomes nice. This is kind of like negative 1 to a power can be written as this. Because when I put the pi in there, I'm picking off the peaks, the valleys, right? And it just becomes alternating. So then you can use alternating series. But it's kind of inherits the problems of 6c. Because natural log of n is not really equivalent to n to any power. It's just weird. It's almost like it's not there. In terms of like investigating limits and series and sums, it's almost like it's not there. And you're like, what the shit? Maybe. I don't know.
Was 1 over n greater than 1 over natural log of n?
Well, here, you help me out. Which one's bigger? Mostly. Well, which one's bigger, period? Isn't that true? Isn't n bigger than natural log of n? Of course it is. So what's true about these? Yeah, 1 over n is less than 1 over ln n. So 1 over ln n is bigger than, so then this could be, if it was 1 over ln n, I could use direct comparison, because it's bigger than a series that diverges. Yeah.
So if you were asking absolute conditional, I could use it.
Totally.
Okay.
Yes. In this case, for this problem, the way I worded it, I don't think I even said to do it, right?
Again, I was just wondering if you're on top of the natural log of n.
Yeah. The answer to this is alternating series test. And then I'm curious if anybody figured out a different test you could use. And of course, we just figured out you could use. Well, direct comparison gets a little interesting, but no, it would still be able to be used. Yes. Is that okay? Okay, maybe. So number 7, I didn't ask you to actually do anything. I just asked you to identify what could work. And I love this question because I push you to go beyond the first thing you notice. So often, more than one test will work. Very often, multiple tests will work, and you're like, I'm not going to use anything other than this one, because that's the one that makes the most sense, yeah? Yes?
Would you want us to do more than one?
Oh, no. The whole purpose of number 7 is very often there's more than one test that'll work. I very rarely would ask you to do something and then do it again using an entirely different test, right? Number 6 is different because I ask you to use tests until you find one that works. I wouldn't ask you to do this one this way, now do it again, use this other way. I don't know, it just feels a little bit busy workish.
And how do you want us to like write the why? Like how expansionary do you make it?
Oh, just whatever you noticed that told you that this test would work.
So just like direct, like be too in depth about it.
Yeah, no, you don't. You could say, I first noticed this, and then I wrote this, and then I realized this, and bam. That's all you gotta say, right? There must be a reason you ended up at considering a test, and I just want you to write that down. What did you notice? What did you write down? And how did you see it would work? Right? Yeah. So number 7 is a very different thought process. A lot of people just start trying stuff without stopping themselves and going, well, what makes the most sense here, right? And I don't blame you because you're like in the middle of a test and time's running out. Like, just try something. But I'm trying to develop that ability to tell when does a test make more sense. Yeah. So on number 7, if you notice, well, I could do this way, or I could do it that way, but why would I ever do it that way? Beautiful. It's a great place to be. Did anyone get 7A, by the way? What test would make the most sense for 7A?
LTT,
Oh yeah, LCD. And what else could you use instead?
ECT.
And if I pushed you instead of third method, interval test, yes, because you could factor the bottom and you could do U sub, yeah. But that would be if I pushed you for a third option, which I could.
You should get extra credit.
Should I? I'll consider it. No. We'll see. Maybe I will. Now listen. I'm really sorry if, please have me restate something. I get excited about the stuff I do, and hopefully you're okay with that. This stuff is so freaking cool. And it always hurts me a little bit that students, the biggest disparity between how much I love something and how much students normally kind of generally hate it is this. It's been this forever. Ever since I first taught this, I was really amazed at how much students seem to dislike this, and I'm like, this was the coolest shit! But it's also the trippiest, not feels like it's based on something, it's kind of like comes out of nowhere at you. Right, you have chapter 7, integrate, and then chapter 11 is like, here's something you've never thought of, and you're like, wait, what? So I understand that, but I'm hoping some of you guys are seeing that this is a little bit cool. Yeah.
Can you talk about read again? Because if you keep, like in my head, if you keep plugging in values, or you keep putting in terms, they're always going to cancel.
That's the idea of telescoping. All right. Here, if I did, let me make one that's sort of like what this one was. If I did 1 minus 0 plus 2 minus 1 plus 3 minus 2 plus, yes? So this, what's S1 is 1. What's S2? 2. So you see that would be 1 plus 1? What's S3? 1 plus 1 plus 1. S3 is 3. Yes? All right. But if you start doing this, of course that's 0. I understand what you're thinking to yourself. You're like, well, they just always cancel. But the idea is, if you look at it as a telescoping, it's easy to make that mistake. And does everybody understand? I love the way you're looking at it, because it's kind of like, if I look at it as a telescoping series, I kind of lose a little bit of the simplicity of why this diverges. This is 1 plus 1 plus 1 forever. But if I look at it as a telescoping, it feels like, well, everything's going to cancel. What's wrong with that statement? That assumes, did everything cancel? Even now, did everything cancel?
No.
If I go one more step, the 3's cancel. Yay! But did everything cancel? No! The thing that is left is getting bigger. Yes? In infinity, I can't get to it. So I don't care where you stop. Whatever you stop, it's going to be bigger than it was the term before. Right? The S before. S7, S8 is bigger than S7. Does that make sense? Okay. But I don't blame you, because when you do telescoping, your brain starts to go, well, wait a minute, everything's just canceling. Why wouldn't it just sum to 0? But if you stop and you look at it as S1, S2, S3, you're like, oh shit, it's just 1 plus 1 plus 1 forever, in this case. Which is basically what the natural laws are doing. I just want to give us better numbers.
So in general, with telescoping, I Is it a good idea to just come up with a summation formula and take the limit of that?
You can, but I wanted this treated as specifically telescoping. And the whole idea of telescoping is you write Sn, and then you let n go to infinity. In this case, Sn would be n, yes? S1 is 1, S2 is 2, S3 is 3,
Yeah.
and the limit of that would be infinity. Our brains go, wait a minute, things are always canceling. No, they're not. They're not always canceling. You're always left with something. That's the right way to look at it. You are always left with something. Not everything always cancels. No, you are always left with. And what's happening to that thing that you're left with? Getting bigger. So there you go. And again, this is another reason why students dislike this more than I like it. I love this shit because it's a little amorphous. Do any of you guys have to take differential equations? Do any of you guys have to take linear algebra? Alright, Diffie-Q is, if it looks like this, you do this. If it looks like this, you do. It's very recipe-ish, and you'll see what I mean. Linear algebra is, that's what it's theorems and just, ooh, what does this do? It's very, and I don't want to scare you, but I love that. I love both of those things. I do. And there's theorems and nothing's concrete and students go a little crazy, but I love that shit. And this has got a little bit of that. Some areas feel less concrete than you're used to, but it's a great introduction to that. And you feel a little uncomfortable with it, and I'm just realizing that's probably why you don't like it as much as I do. Sorry, go ahead, please.
Can you, for number 4C, is that just extending the total and other things like complementing?
This one?
Yeah.
Oh! Yeah, you can simplify that right off the bat. Yeah. Dear God, this applies for sums. If I give you a summation and there's algebraic stuff you could do inside of it, do it. What do you do before you attack it with calculus or you attack it with series tests? Simplify it, right? So, like you said, I could cancel basically a ton of shit, yes.
And then would I have to explain my divergence or just
I mean, what are you left with?
one word?
Yeah, so it reduces to a known series. Now, I do want you to say either P series, P is not greater than 1, or harmonic. Either one of those tells me, okay, you know this diverges and why.
So for like every question that asks us if it converges or diverges, you just want us to say.
Totally. So when you do integral and you get a finite answer and you just say converge, why is that not good enough? Why might you lose a point or two? If you do an integral of the associated x valued function, you get and you say converges. Why is that not good enough? The integral converged, and what do you have to say after that? Therefore, our series converges by the integral. Yes. You guys kind of with me? I because the tests have different ways to interpret the answers, and I'm trying to help you realize, without just straight memorization, why their results mean what they do. Yes? I'm trying, the limit comparison, we talked about why it's got to be a finite number. We talked about why that's true. So it's less memorization and more just what makes sense. We have more tests in our future, and we'll see how that goes. Is that okay for that one? So that one basically just becomes a series that we know. I mean, it's almost like if I gave you this problem here. What does this do, kids? Do you have to do direct comparison? Do you have to do... No, what do you do? Simplify. 1 squared, P is 2 greater than 1, converges, yeah. Right? I mean, to be really honest, do you all agree this is dumb, this is silly? Mm-hmm. All right, this is just as silly. It's just using a function we're not as used to. So it feels like it's supposed to be more, but factorial is just this dumb function. I can simplify that. Becomes a series I know. What do you do? Okay. I like it. Yes?
It's
the one I couldn't do. No, let's see, all right. So what's up? There was a problem, at least one problem in the homework like this, if I remember correctly. Do you guys see what 4B is composed of? Huh? Boogie, woogie, woogie. How many geometric? Good. It's got 2 separate geometric series in it. So I get a few, well, please, dear God, don't make the top become 3 to the n plus 2 or something. Yeah. That's not like don't do it. So I have to break this up. So this will be 1 over 5 to the n minus 4 to the n plus 2 over, and if you want to, you can take 16 out, blah, blah, blah. Yes? Do you guys see that? So each one, you can see what R is. In order for the whole series to converge, both of those series have to converge, yes? If either one of them did not converge, the whole thing would diverge. Does that make sense?
Yeah.
Yes?
So, I know you broke up into the first one, the second one, how is the top and plus 2 and the bottom is?
Do it again, sorry.
So the second one that you're subtracting, it has
Yes,
a
yes.
different exponent?
Doesn't matter. And I apologize if I've made too little of this. I can see R is 4/5, right? I just know it. And if you want to see it better, this specifically, I can rewrite as, just looking at this piece. This would be 4 to the n times 4 squared, yes? Which is 16, 4/5 to the n. So then you can see it pacifically. Do you have to do that for me? No. No. We should be good with going, well, R is 4/5. That's 4 to the n, 5 to the n. R is 4/5. What do I need to figure out if it converges? I just need R.
Yeah.
Yes? And if R is less than 1, it converges. Absolute value of R, but in this case, they're both positive here. You guys with me?
Mm-hmm.
And then what do I need to get the sum? I need R
You need A1.
and you need A1. So like I said, I've said this before, I do not need you to put geometric series in standard geometric form. A1 times R to the n minus 1. I don't need that bullshit. We can see what R is. We can calculate what A1 is. Now, if you like putting it in the form, do it. I'm not going to stand in your way. I'm just telling you don't need to. You can pull out what you need. You guys with me? Is that okay for that one? Okay. Does anyone else still feel weird being here? Sorry, I got so used to not being in the city last week. It was great. Nothing against the city. It's just anything else? Did anyone try just for a second, did anyone try the extreme bonus? You don't have to think about this at all. If you just went like, no, you're fine. The whole point of the extreme bonus, and I did write some considerations. I didn't actually take it all the way out. We're going to talk about. The whole point of that is none of the tests we know actually work. And of course, I'm doing a very teacher thing. After the test, we're going to immediately learn something that will work on this. And there's a really cool structure inside of this that becomes obvious if you mess with this a bit. Sort of like that one you just asked me about the n minus 1 factorial. Stuff cancels and it should actually become geometric. It should become like it wants to be geometric, but it isn't. Anyway, sorry. So we don't have to talk about that at all if you don't want to. I put some on the answer key, some considerations. What have we not talked about? How'd this one go? Yeah, like this is A1, so this is 1 over 1 plus 1. But this one is 1 over, this is A2, this is 1 over 1 plus 2, square root of 2. So this is 1 plus 1 square root of 1. Okay, see, as you do each thing, you can kind of go back and make adjustments to earlier ones so you can capture where does n go. What's staying the same? What's changing? Whatever's changing, that must be related to n. Are you guys with me? So I see in your homework that I'm grading, a lot of you guys are in web design, so I was about to say the little bit of homework I get, but a lot of you guys are in web design, which is fine. That it seems like you guys kind of get the idea, trying to break it down, figure out what actually is changing so you can identify where n goes. And then what is this fundamentally? I didn't get specific on this one. No, I'm just realizing I'm reading that wrong. I thought I had some minuses in it. It's not all thing. This just becomes 1 over. Yeah, and then you can do like direct comparison or limit comparison, right? It's trying to be a p-series. Okay. We talked about everything? What about this one? Ivan has a really good idea. What's the degree of the top? What's the degree of the bottom? Okay. And letting n go to infinity, what's the very first thing you should try if you're not sure? Test for divergence. Yeah. So that limit is not 0. What if the limit was 0? What would that mean? Possibly convergence. You go, damn, now the real work starts. Yes? So just doing the test for divergence is just seeing, am I done already? And if it's 0, you're like, no, I am not. I'm just starting. Yes? I still get so many people take the test and they'll say, limit is 0, so it converges. And they do that, and I'm like, oh my God, you just lost half the point with the shit. Limit 0 just means the series might converge. Yes? How do you check that a sequence converges? All the limit has to be is a finite number then, yes? But if I'm adding the terms up, the limit has to be 0 for it to possibly converge. Yes? I don't blame you for getting it mixed up. Your brain desperately tries to make quick shortcut ways, but you're like, stop it, brain. Nope. That brain, you gotta keep on top of it. Yes? Sure. I love number 1 because it looks so trippy. I love number 1 because it's, all right, I do want to say, number 1 is simple, but when you first look at it, you're like, what the shit's wrong with this guy? Why are you shoving trig in there? What the hell is wrong? But I mean, for any value of theta, and I say specifically, it is for a value of theta. Any value of theta, what kind of series is this? What is sine theta? No. Any given value of theta. Is theta changing? What's the only thing changing? N, yes? Theta is a constant. For any given value of theta, what is sine theta? And I don't want a number from you because I didn't tell you what theta is. What is sine theta? Is it a function, or is it a constant, or is it a... For any given value of theta, sine theta is a constant. What's sine of 60 degrees? Sine of pi over 3. Pop quiz! What's sine of pi over 3?
Root 3 over 2?
Root 3 over 2. Sine likes y. The closer I am to y, the bigger sine is. If you know SOHCAHTOA, I'm sorry. SOHCAHTOA sucks. If you know sine likes y, everything else makes sense. Sorry. If you know SOHCAHTOA, it's fine. It works. It just doesn't do much for you, to be honest. Okay, so coming back, for any given value of theta, sine theta is a number. 1 over n to the number is what kind of series? P-series. And what does it take for a P-series to converge?
Over 1.
The P has to be greater than 1. In this case, P is sine theta. What's the biggest sine theta can be?
1.
So for what values of theta, or I like the way I asked it less trollish there. Is there any value of theta? No. Because every value of theta would end up with a P less than 1. Or less than or equal to 1. Is that cool? You can see that? So I love that because when you first look at it, it looks so trippy. You're like, why is there a trip function in there? What did you do? You got chocolate and peanut butter. Is that old commercial reference? And then, of course, I mean, just to push the trig thing, I am going to obviously do this. I have got to keep trig alive in your brain, so I'm going to have problems where I want specific, not approximations, I want exact answers. So don't be plugging shit in your calculator when it's like sine of 3 pi over 4. You should know what it is. Yes? Screw you, Jeff. No, too bad. You should know. Okay, I think, here, let me give you the answer key. So you can look this over and see which ones I made mistakes on.
First thing.
Oh,
What about the other one?
I have like literally 11.1 and 11.2. No. 11.3 is on, no, 11.2 is on the scan, 11.3 is on the scan, 11.5 is on the scan.
What's that? Yay, more of Jeff's Friday. Oh.
I told you it's gonna be geometry.
I created this answer key in the Luna Cafe in Cayucos, California. I brought a lot of work with me. Let me know if you think I've made a mistake, and just a human. Yes, sir. Oh.
No subject.
Oh, no, this is totally obvious. Like, that one is smaller than that, so this is bigger than that. L. Yes. Step by step.
Already?
You did too many.
Yeah, I thought we were
I don't see the logic.
So we have 7 months. Well, that kind of, this 8
So do one thing at a time. So like if you take a plus one away, you made the bottom smaller, so it's bigger. If you take the minus one away, you make the top bigger. It was bigger. I need to see kind of a chain of thought. So it's not to me, it looks like you're just saying what you want to be true. I don't know if you're actually making sure that it's, let's say, seasonal thought. Does that make sense?
Yeah.
Okay. So don't forget, you can ask questions from like quizzes you're making corrections on, homework, whatever. If anyone's asked me anything on WebAssign, I haven't looked at it in a while, so I'm sorry. If you ask me a question on WebAssign and it's been a week, just email me normally and say, Jeff, get your dummies in there and take a look at what I'm trying to say. Maybe don't say that.
I have one question.
Yes.
It's just clarification. So obviously we know that at least for this one, it's after the convergence. So
Yeah.
we just tested for the after
Absolutely,
convergence.
yeah.
But when we say series is absolutely convergent by the test that I use.
Yes.
Okay.
Yes. Yeah, absolute convergence is just analyzing the series that you get if you take the absolute value out. And then it has a test you could use. Yeah. So I want your result to be dependent on that test. There's no like absolute convergence test. Because it depends on what kind of
I'm
series.
assuming you don't have to choose check for absolute for this one because it's one over. It's trying to one over n, right? So we can just
Yeah,
go
totally.
straight.
Yeah. I mean, and you can say that very quickly. It won't be absolute because it's trying to be 1 over n. Yeah.
It was that question also. I understood, I remember you said, oh, you want to compare it to create this would be the why can't I
Why can you not? What can you want?
compare it to this?
Why can you?
Cannot.
Why can't you?
Yeah, because I looked at the answer and it's like, oh, you want to compare it to 1/2 of 1/3.
So you've made the bottom smaller. The whole thing is clear. This converges, so therefore this converges. What the book said?
The book said they created this as a big and then they added together.
The book had different.
And then they had a way bigger.
I see. So instead of deleting one, they made them like terms. The other one. That's good. Yeah, the book is done.
I like government.
This one
I think
actually.
government is like.
I did say that.
So you found that the area that the book found is worse?
Yes.
Okay, that makes sense.
For this one, I couldn't figure it out. Because it may have been his version.
Let me look it up. 52 where?
11/4. I mean, I don't care about the. I mean, I can see a convergence if I compare it to a series.
Let's see. So guys, I got a question from 11:4. This one?
Yeah.
Show that if I have a positive value sequence and this is convergent, then this is, ooh, I like this problem. Sorry. Okay. So they give us that if I just have the sum of an, I know it's convergent. And they want us to test this. So, and this is in section 11.4, and 11.4 is the comparison test, right? Okay, so what would you try?
I tried to compare it to a known series that is convergent.
You could try which one?
A known series that's convergent?
So you did direct comparison. Okay, because you could do limit or direct. Okay. So how did you start that off? If you're doing direct comparison, you got to make a chain of inequalities. You know this is convergent, so you want to show that this one is related to this one. How? All right, listen. Since we know that's convergent, they're telling us to show that it's convergent. So we know it's convergent, so we want to find a ceiling, correct? So we want to show that this is eventually less than this, yes? Because if our series is less than something we know converges, then our series converges. So you have to figure out, starting with natural log of 1 plus a sub n, how do I make that show that that's less than an? Yes? Okay. I don't know. What have you tried?
I mean, I just tried looking at it. I said a of n equals 1n squared, but then I was like, I got lower from there.
Okay. Well, I'm zoomed way this shit. Okay. Focus. Okay. So I need to show somehow that this, we want to show that this is less than this. Okay. So, what could you try to do?
Would a sub n be inherently bigger
Do it again.
Would it be inherently bigger?
Why inherently bigger? That's a big claim.
Because natural log grows slowly.
Natural log grows slowly, sure. You could try to do something to show that there's a certain value of n, but we don't know what an is, right? All we know is an converges. We don't know what the elements of an are. Yes. Oh, and an is positive, by the way. All the elements of an are positive, which is important.
Could you use the property of ones?
Oh, I see. That's backwards.
Okay.
The log of the product is the sum of the logs. The log of the sum is it. It doesn't go anywhere. But not a bad thought.
Can you make
Did anybody else try this problem out? Does this look familiar to anybody? You're like, no, because I looked at it for a second and thought, you won't notice I didn't do this wrong.
Can you make an something?
Do it again?
Can you make b sub n something like a known series?
No. Because that would be, you're proving it specifically for that series. This wants it to be true for any series where what they said is true. Yeah. I don't know. Did you consider trying to use E somehow? I'm just throwing thoughts out there. Like, if... So, this doesn't have to go anywhere, but do you agree with me that this is less than this? And I have to be careful about this, but this is, if an is positive, natural log of 1 plus an is bigger than 0. Yes? So that should be okay. I have to think about it. But I mean, you can kind of, that's the kind of messing around with this that you want to do. Now, this gets you to somewhere less than optimal necessarily, but it actually, no, maybe that's exactly, holy shit, okay. Now, this is the first thing I thought of trying, because normally when you have a log in your way, you do this. Go down this path. This might actually get you somewhere good. Real quick, let me give you one little clue. What does this do? What's the problem say this does? So what does this do? Okay. You're like, you said that like it's just the answer. It is. It's the answer. QED. So listen, this is I love giving these problems. And I love that my colleagues, some of my colleagues said, Jeff, what's the matter? You're not too fun. I'm like, you should be cool with playing with this shit. Don't give me that. So I think I've told you this. Some problems I've assigned are meant to push you a little bit. And if you're like, I've been pushed enough, then pass them by. It's okay. It's supposed to be play. I assigned certain problems. I didn't assign other ones. Could I have not assigned one of the problems that's giving you issues? I could have. So how important is that problem really? Not. But I do want you to try and just play with it a little bit. Just the process of playing itself will make you realize what could work. So that's, to me, homework has to have some of that in it. Not these clean cut, oh, it's this, so I do this, and and that's what students want. I don't blame you. But I hope some of you guys want, wait a minute, what? Let me just try something. Beautiful, that's a great place to be. Just try something, that's the whole idea. Hopefully what you try you're using legally. Not like there's a math prison you're in trouble of getting thrown into, but. So if you really hate that I did that, oh well, too bad. Trying to do the best for you, no matter how you feel about it. So what I'm saying is if you don't finish every homework problem, it's not the end of the world. It isn't. It isn't. Nowhere near. If you do most of the homework, you're getting a pretty good chunk of practice, and that's what's most important. So if there are some problems that are weird. If you give me something, some thought process. And I understand if you're a student who's like, no, Jeff, no, I've got to finish every problem. Like, I'm really sorry, then come see me. Come see me. I'll give you some more ideas. Yes? Yeah.
For number 4, you said it diverges by TFD.
TFD? Oh man, was I inebriated? Which one? Which one?
4.
Oh, test for divergence. Yeah, I'm sorry. My head was making it FTD, and I was like, I definitely didn't mean that. Yeah, test for divergence. Yes. Number 2. Yes.
Is it just making the function a little bit, or?
Yeah, so I've given you a sequence. And how do you show a sequence converges? Show that the limit is finite. Yeah. So just take the limit. And since tangent's continuous on its domain, you can take the limit inside of it, right? And then you can just attack the inside part directly. And the inside's just polynomial, rational function, polynomial ratio. Is that cool? So you know how to do the limit as n goes to infinity? Yeah. So as long as a function is continuous on its domain, you can take a limit into it. And number 2 is important, and I'm going to put some sequence-specific questions. So you have to be really careful. Am I talking about a sequence, or am I talking about a series? Because a sequence converges much easier than a series does. So what tests do we know, guys? We know test for divergence, p-series. P's got to be greater than 1. What else do we have? Where did p-series come from? Where did p-series come from? Integral test. Yes? Integral test is where p-series came from. What else do we know?
Comparison.
The 2 comparison tests, direct comparison, limit comparison, and then alternating series test. Yes? And of course, alternating series has the idea of absolute versus conditional convergence, and that's just a little more specific. It's sort of like when you took a limit and you said it did not exist, but you should have said positive infinity or negative infinity. So technically you're right, you just weren't specific enough. If I give you an AST and you say it converges, you're not specific enough. Does it converge conditionally? Absolutely. People like us enough to help us. How many guys are taking Calc 3 next semester? Okay. Can't remember off the top of my head who's teaching it. I'm not teaching it.
It's green hack and it's gonna be
It's either lines or fun.
lines.
No, fun is hybrid.
Oh, it's fine. It's fine. It's so weird to me that Ray's gonna be gone. When I first moved here, he gave me a couch because when I got here, I shoved all of my belongings, and I sell a lot of my stuff, and I shoved the rest of it into this little tiny trailer, U-Haul trailer. So when I got here, I had a mattress, and I had a table, and then Ray's like, I got a couch you can use. Thank God, I got some actual furniture. It's amazing. Anyway,
Still have a couch?
huh?
Still have that couch?
No, that couch got torn to shit, man. That couch gave up eventually. It was already old when he gave it to me, but it was, old couches are great. They're so comfortable. Anyway, it was completely unnecessary. So I'm sorry. There won't be anything on the test about who gave me my first couch here in the city.
So you get extra credit if you
Sure.
Let's go.
Totally. I'll give you the limit as n goes to infinity of 1 over n
Was it
points.
feathers?
That's more than 0, by the way. Maybe not the limit, but like the number you get. I'll give you the last digit of pi. That many. Well, that's what my PIN number is, the last 4 digits of pi. That's so dumb. Anything else you guys want to focus on? Because, like I said, I got nothing else. I think we talked about every problem on the freaking practice test, did we? How you guys feeling about this? Do you even know how to study? So what I would do if I were you is I would make sure I completely understand each test by itself. Because there's 2 layers, yes? There's, do you understand how I apply a test? What's the requirements? Do you know how to show them? How do you interpret the results? Yes? Do that for each test. And then the next layer is, how do I tell when to try which test? And that's a whole other skill, yes? And that's basically all math is. The hardest part is, when do I use this? Like, I know how to do that. When do I use that? I hear that all the time. That's why I try to give you some problems with this practice test that kind of force you to see what it looks like when something doesn't work. What else do I try? That one problem where I made you try several in a row. Yes? And like I said, if I ask you on the test to do a specific thing, you're like, I have no idea how that works here, and you do it some other way, you're not going to lose all the points. You're going to lose most of the points. But you're going to get more than 0. Does that make sense? So, I mean, at the very least, do what you know you can do. And I am going to give you some problems where I'm just wide open. Whatever you think of, try it. Good. Yes?
So I asked this earlier, so I asked if I can use the interval test on number 2. I still wrote-
Oh, number 2?
Yeah. I
Oh, I'm
still-
sorry. I thought you meant number 3 earlier.
No, sorry, number 3.
Oh, okay.
I
Number
still
3.
wrote it as a telescoping series. I just used the interval test on that class.
Interesting. What'd you get?
I got that.
Well, the interval of that would be like infinity minus. Well,
No, if you simplify it, it's actually infinity plus infinity.
okay, maybe. Because the interval of ln is itself like n ln n minus n.
There is like there's like one x ln x minus
X.
some other x ln x in that form, and you can factor out the x, and then you can use the quotient rule.
Alright. I got you. So you would, on a test, I would give you some, especially if it was like applied correctly. Because that one does require some creativity in analyzing the intervals. So I wouldn't give you nothing, but you still didn't do what I wanted. Right?
But it's harder that way. So in a way,
No, in a way I should give you less points. Right? And I'm like, why are you making this harder on yourself? Because part of the class is trying to figure out what's the best way forward on some of these. And don't waste time trying to get the best. Very often you just do what comes to mind first. Because a lot of you students, I used to be like this, I'm like, no, it's gotta be a better way, and then I'm like, just do what you're thinking, Jeff. Good board. We only have so much time. I'm not sure what else to say. I've said everything. So eventually, I mean, after this test, we're going to learn some more some more series, convergence, divergence tests. And then I have a handout that I actually gave to some people in the CISL, and it's got all the different tests and when they work the best, what the outcome means, blah, 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 right? All right, I don't want to talk too much about the future because we're going to focus on this test. Is there anything else? Anything else? Any other problems from homework? Anything that still didn't make sense after we talked about it here? One option is always to go, hey Jeff, you talked about that problem, but you made 0 sense to me. Can you try it again? And I'll try it again. That's my job. Yes?
What do we have a formula on the test? Did you see the test?
What now, sorry?
What do we have a formula of like how to do the test?
The formula.
Like showing like the interval test.
Oh! Nope. You have to know all the tests. Yes. I have no idea what my colleagues do. I feel like some of them give way too many cheat sheets out. So if you wanted that, you've chosen poorly. I'm really sorry. I tried desperately to show you how you do what makes sense. You don't have to memorize everything. If you understand why things are the way they are, what they're based on, you're doing less memorization and more, don't put your hand on stuff. I don't have to memorize that shit. You know it. Yes? Makes sense. What's this gonna do? Oh, that's bad. I remember. Yes?
15 from 11.5.
I don't know. Let's see. This one here? So it's got a trig function in it, which kind of makes you consider possibilities. 11.5 kind of gives it away a little bit. Because 11.5 was all about alternating series, I believe, if I remember correctly. Yes. That was one thing it was about, right? This one is funny. Oh, it's also, oh yeah, that's right. There's a problem with the practice test. It's sort of like this one. Try to, if you put a 0 in, what's the top? Sine of pi over 2. What's sine of pi over 2? 1, because sine likes y. 90 degrees, it's all y. I consider sine, mathematically this isn't quite right, but sine is like the percentage of the hypotenuse that's in the y direction. At 90 degrees, it's 100%, so it's 1. Yes? If I let n be 1, what do I get? Sine of 3 pi over 2. What's sine of 3 pi over 2? Negative 1. Sine of 5 pi over 2? 1. Sine of 7 pi over 2? Negative 1. So what is this really? What can you replace the top with? Negative 1 to the n. Yeah. You guys see that? It is because, now the way they wrote it is dumb. Do you guys see a problem with the way they wrote it?
The pi is not.
They really should have it like this. It's not like that times pi. That's not what they meant.
The pi
Trust me.
is-
So I don't know if that's what gets you in trouble. I don't blame you. They wrote that stupidly. They really needed
So
like,
would 16 also be cosine of n?
yeah, no, this is better. This is fine. This is understood
Okay.
that that's together. Yeah.
So it would be the same, the pi is.
Because, and this is
Those are
actually
pi over
not
2.
terrible, because if they truly meant pi to be on the outside, we would always write it as a coefficient. So this isn't
Yeah.
terrible, but it's not good either. So I don't blame you, that was the issue. I don't know if that was the issue. I already forgot who asked the question. I have no memory. Oh, I'm sorry. Okay. Where am I? Oh. Does that make sense? So that was alternating series, just like the one on the practice test. Was cosine n pi. I had one on the practice test just like this.
Yeah.
Yes. Yeah.
So is that whole thing negative 1 to the n, or is it?
Yes. All of this is negative 1 to the n. Now, I told you before that you cannot get general things from specific instances, yes? But structurally, I see that this is always going to go by half pi, by 90 degrees. So structurally, I see that's going to continue forever. I'm not making a generalization off of specific instances. I did specific instances to realize what's happening. I don't know if you guys are with me. I can't do a few elements and go, oh, that converges. Because who knows, maybe it's like this and it goes, wah! You don't know. But here, the structure of it, I go, oh shit, I see it now. It's multiple. It's multiples of 1/2 pi, and that sign's always got to be 1 negative 1, 1 negative 1. You just plug a few numbers in to kind of see that that's what's happening. $17 is neat. I like 17. And 18 is the same problem. 18 is even neater. Can anyone do 18 really quickly? Do you have a clue? Is that geometric? Is it P series? Is it anything? You don't have a clue. So what do you try first? What do you rule out? What do you try first on number 18? Test for divergence. What happens when n goes to infinity?
0.
This will be cosine of 0. Yes, and what's cosine of 0?
1.
Okay. So the limit's not 0, so it doesn't converge in any way. Not conditionally or absolutely. I'm done. Test for divergence, done. You guys see that? That's a really good example of, that is weird. That's not like in a form of anything. So then I'm like, okay, I'm going to try test for divergence. That's what you should, if it's not P series, if it's not geometric, if it's not obvious, if it's not direct comparison, because you can see it's trying to be P series, you go test for divergence. Save me. What about 17? Does the test for divergence save us? No, but the limit is 0. It is alternating, so it's the one thing extra you need. What's the extra thing for alternating series? You have the limit is 0.
Not increasing.
It's got to be non-increasing. And how do you do that?
What if it doesn't?
Huh?
It doesn't. It's always in its own.
For this specific problem, oh god, nobody's asked me questions, so I'm just going to kind of go off for a second. For this specific problem, when I put n equals 1, it's the sine of what? Sine of pi. And what's sine of pi?
0.
0. Yes, so sine of pi is 0. If I put a 2 in, sine of pi over 2, yes? And that's 1. So that is not decreasing, is it? But forever after that, are my inputs, forever after that first step, isn't it decreasing now? You could actually argue that visually. There are so many other ways I can accept an argument. So often you just have to give me some thought. Don't just go, decreasing, check. No, what the shit? No, you just know what to say. You gotta show me you actually checked the damn thing. I don't know if you guys are with me. You could take a derivative. Yes? That's a really good way to do this, because the derivative is going to be negative. Do you guys see that? And the outputs of sine are positive for the values we're looking at, so therefore that's decreasing. Except for that first step. I don't know if you guys are with me. I'm so chill. Alright. That's neat. I like those problems. I wish I hadn't talked about them so I could have made them a problem on the test, but it's too bad. Yes?
On the test, are you gonna be very serious on converging it to real numbers, or not natural numbers, but in terms of x? So when
I'm
you take
sorry,
another-
strict. Are you gonna be strict about turning into like a f(x) function?
Oh!
or like an integral, like
I'll probably put notes on there. I don't, as a student, I was always looser with that. As a teacher, it's very, I understand the importance of, and as a student, you should understand the importance of the distinction. On the other end of it almost doesn't matter. It's kind of like the work in between, especially if you're not submitting a paper to some journal, it's just work. So if you don't have it perfectly annotated, it almost doesn't matter. But as a teacher, I have to make sure I've stressed enough the need for that. Because an n-valued function, you can't do calculus to it, right? But it's almost secondary to what's important here. Does it make sense? So it's always a weird competition for me. I want you to know how important it is. That's a really important idea. At the same time, who gives a shit? It does nothing in terms of helping me figure this stuff out. So I would probably at least put a note, like, you need to make this X, just to really just make sure you understand this is generally important. Yeah. To try to do that for something official, they would laugh you out. Yeah. But you know, how official am I? Enough, I guess. Alright. Anything else? By the way, you guys, some of you guys are looking at me like, please shut up, Jeff. Just leave. If you're ready, you can go. I see some of you guys are clutching your stuff. But I also understand you're like, I don't want to leave if somebody asks something good. Yes?
That paper you briefly talked about, having all the tests on there, do we just go up to the sister for that?
Oh, no, I will eventually give it to you guys.
Oh.
I don't like to give it too early because it's got stuff we haven't talked about yet.
Oh, okay.
So it gets a little confusing if you look too far down. But I did bring it to the CISL because I think it's generally good. And I think a few students asked me specifically, do you have something that has all the tests on it? And I'm like, I have more than you've done. I'm like, okay. I'm like, okay. So you're going to get it from me.
Okay.
And you can go up and get it. It's not like it's going to damage you. But just, there's stuff in there we haven't talked about yet.
Okay.
Yeah. And I am so cool if we end early, because this morning was insane. I'm also cool if we stay the entire time, if anyone has questions, because I like my job. So don't feel like you're doing anything with me if you leave now. But if you have questions, let me know.
I get an A on the
Huh?
I get an automatic A on the test.
Automatic A? I didn't think about it, no.
I was wondering if, I mean, it's not even about the material here, if this process for mathematical induction is like acceptable.
Through is divisible by 3, okay. Oh, neat, okay.
Like not,
In this specific example, sometimes we might have to do 2 base cases, because 0 is sort of like a trivial.
Yeah, but
Right now.
But I mean, as long as you show it is true for 1, so to be honest, you don't have to. Because if you show, let's see. Okay, I got you.
And homework is 10, right? Or 10 or 15.
Here's the issue.
Yeah.
M here can't be the same as it is
Actually,
here.
different.
Yeah.
Okay, that makes sense. Not
Which
bad.
shouldn't lead to major
I
issues
think
for
it's
you.
10 or 15. If it's high.
It should still lead
I
to
did-
something
I
that's
did-
obviously works. That's the one issue I can see. I think the rest of it, just glancing at it, looks
I would not stay here if homework was 25.
This is here.
Check and K plus 1. I will
So
see.
you assume this is true,
Yeah.
and then you want to show. No. You assume this is true,
Yeah,
and then you want to show this, and that's why these can't be the same.
yeah, that makes sense.
Okay.
So,
Yeah.
I have a question, so for the test corrections, do you pull the test?
Yes. Cool. Thank you. Hopefully there's.
So it's even longer. Because I have 50%. No, like 40%.
I fixed it a little bit,
Oh, I think.
Like I'll pass, but.
Yeah, it should have been. Let's see.
Did I write them?
It's not nat log squared e, it's natural log e squared. This actually doesn't make sense. So you're not squaring the natural log, you're squaring the e. In which case, the natural log of e squared is 2. Yeah, does it make sense? So at 0, you kind of made the same mistake, but you just changed where the math happened. Since it's natural log of t squared, if t is e, natural log of e squared is 2, because the power e needs to become e squared is 2. Does that make sense? So look. This would be the best way. I think you did it right here. No, but do you see how you could take? Let me go back to the property of the logs where you could take the power down. So that 2 could just come out front.
Oh,
So 2 times natural log of e is 2 times 1 is 2.
okay,
Yeah.
thank you.
You're welcome.
Can I know what problems are like the most important in 11.4 and 5? Or can I just send you a message to them?
Are you worried because you don't have time to finish the
Yeah.
homework? Oh, then kind of do every other problem
Every other,
that I
okay.
assigned. You know what I mean?
Uh-huh.
All that matters is you get a broad
Okay. Yeah, I was just
swap.
asking just in
There's
case
none
it was,
that
like
are
a part
necessarily
that
more
was,
important
like,
than others. It's just the idea of getting like fractions of a lot of different looking things.
Mhm.
So if you can't do every one, do every other one.
Okay.
Yeah. Cool. You're welcome.
And I just wanted to be clear, is this what you wanted me to show you specifically?
Yeah, this will show me. I need you to understand, and I understand this frustrating. I do. But this will tell me that you put thought into why each one of these is true. It's kind of like you could in your head go, oh yeah. Even if you did that, I still would want you to say something. But it's just cleaner just to do this. Because then I can go, oh, he actually stopped and thought about each thing he was doing. You see what I mean? Yeah.
Alright,
You-
and I don't know where to put this.
Oh yeah. So always this one file right there. Yeah.
Alright, thank you.
Sure.
Do you know my current grade, including homework?
No idea.